Hi all, and welcome to yet another Lunar Lander tutorial here on UnityCookie.com. We had a couple requests for some additions to this game before we call it quits. I definitely want to hit those up for you guys. So it looked like the big ones were having a fuel system, music and data staying between levels, and having the camera follow the player ship, kind of like in the original demo that I showed off and then did not describe. So we'll be going over those three things, and we'll start off with the fuel system. So for the fuel system, I've created two new GUI elements, the fuel meter and fuel meter border, and these are again things you can easily recreate yourself, and I'll show you real quick how to do that. So the fuel meter is actually just a 2x2 texture, nothing special at all, and we're going to sort of scale and stretch it to look like a fuel meter going up and down, so that's why it doesn't need any real pixel dimensions, just a nice power of 2 number there. And the border itself is just something that'll make it look a little neater, so we can put it inside of that and have it look like a real GUI element. So we'll add those right away. Take the fuel meter border and just go gameobject, create other GUI texture as usual. And we want this to always be in the upper left hand corner of the screen. So I'll put its position on the X at 0 and Y at 1. And of course it's a little bit off here. All we need to do is use the pixel inset and set the X to be 0 and the Y to be -64. 0 because and say, sorry, 0 -64 because for GUI textures they're always measured from the top left corner here. So it needs to be 0 over, it's right on the edge, and 64 down. Or, I'm sorry, the the bottom left corner I meant to say. So it's 64 tall, so we bring it down 64 and 0 over. So there we have that. And that'll stick, of course, right there no matter how our scene moves. So it should be just right. Okay, then the fuel meter itself will drop in there. So with that selected, we'll just drop in another GUI texture. Of course, it'll come as a tiny little dot there. And we just want to set it so it fits inside of here. And I happen to know when I created this texture that it is, let's see, on the width 80 pixels and the height is 20. So I'll set that. And then again with this we want the X to be 0 and the Y to be 1. And that's just, again, so it sticks right to that corner. And in the case of this, it's now up and gone, disappeared, so we'll just need to move that over on the X a little ways and down on the Y so we can start to see it, and just do a pretty good job of setting it up so it fits in there. If you end up with any non-exact numbers like 30.3 or something, it's probably best to set that exactly to a number. In this case I'm going with 14 for the X and -30 for the Y. That looks good there. Lastly, we'll set a color on that. Something pretty close to exactly the center of green, and we'll go over why on that a little bit later. So it doesn't have to be exactly perfect, but get it as green as possible. So that looks about right at 23, 255, and 0. If I wanted to be perfect, I'm sure I could figure out an actual exact number for that. Or I could just do that. So red of 0, green of 255, and blue 0, of course. Ta-da! Okay, so we've got our green set up. Now we want to actually make this animator actually, scale down as you use up your fuel. And on top of that, we need to actually add fuel to the game itself. So let's take a look back at in the scripts folder, the player controller. And if we open that up, what we basically want to do is have a starting fuel and just obviously subtract from it constantly whenever any of the thrusters are being used. So I'll go down and use the area under here where I was setting the audio, because this just checks always, no matter what, if we have any sort of thrust going on to this. So we can use that also for the fuel. And first, I guess we'll set up some variables up top here. So we need to have a fuel burn speed. This will be how fast the player ship uses up the fuel. And that's going to be a float. And we'll have a have fuel, and that'll be a boolean. just whether or not the player still has any fuel, and of course the actual fuel amount, how much fuel is left, also a float. So once we get those, we can go back down to the area where we'll be adding this info in, or I should say using this info. And we'll want to just remove some fuel every time the, oops, wrong area here. Don't watch that, up here inside of the input.getAccess vertical or horizontal after the audio. We want to check if any fuel is being used. So I'll just add a little notation here. Check if fuel is being used, subtract if so. So if the fuel is being used, we're inside of this if loop here. We want to subtract a certain amount, so just go fuel amount, and we could simply say minus minus, right, and just subtract. I guess this would actually be 1 per each time that we check this. The problem is this is running per frame, so depending on the speed of the computer, their fuel would actually go down differently. So the slower computer you had, the slower your fuel will go down, and the opposite for a slower computer. So we use a little bit of what I consider Unity magic here, maybe more familiar to people who've done more coding, but they have a time.delta time option. So basically I can multiply the fuel burn amount, the amount we want to burn per second, times time delta time, which will get the change in time since the last frame. And if that sounds a little confusing, don't worry about it. Just remember, always use this whenever you want to do things per second versus per frame. So it's useful. You'll see. So fuel amount minus equals, so we're going to subtract this amount from it. And then we type in just, let's see, the fuel burn speed times time.delta time. And what that is going to do is simply remove fuel per second at the rate of the burn speed. So I'm going to fix up this comment so it makes a little more sense and just say remove fuel per second. There we go. Now once we've removed that, we want to go ahead and check if we've got 0 fuel at this point. So we're doing this every single frame, of course. So if fuel amount, so if now that we've removed some, if it's less than or equal to 0, then we want to do a couple things. Number one, we don't want any negative numbers on the fuel amount, of course. So if it's less than 0, we'll just straight up hit it back to 0. So we'll say fuel amount equals 0. No reason for it to be any less than that. Of course, have fuel now equals false. And then we want to, oops, don't forget the semicolons at the end there. We want to do a couple things just to stop any kind of action going on. So we'll stop the audio and stop the thrusters from emitting. So audio.stop. And then for each of the thrusters, I'm just going to tell them their emit to be false. So I already have this typed up. I'm just going to paste it in so you don't have to watch me type each of those. So emit.false, or equals false, I mean, for each of the thrusters, and that will turn off any kind of thruster action and sound and such we have going on. Okay, so after that if, and again that's just checking if we've ran out of fuel. Comment that. Ran out of fuel. So no matter what, whether we've ran out of fuel or not, we have to update this our GUI texture over here, and we'll do that by making a call to the GUI itself. And if you remember up here, we have set the GUI to automatically connect to the in-game GUI. So we can say GUI dot do something. In this case, we're going to create a function in the GUI script called update. Update fuel meter sounds good. And we're going to send it the fuel amount that we have right now. So whenever you create a function, this is something new I think, you can have it receive a variable as many as you want actually, I believe, within reason of course, and then use that. So it makes it a little easier so you don't have to send or call this and then have the other script look back and get this number. We can send it right with the same function call. So we'll do that. Save it. And if you try and go in, we will get an error here. wait for it. There it is. So update fuel meter is not a member of in-game GUI. That's simply because that function we want to call obviously does not exist yet. So let's go ahead and create it down at the end here. So now I'm back in, back in the in-game GUI script. So function update fuel meter. And inside of here, instead of just being as usual like all these others, nothing inside of the parentheses, we're going to add, let's see, new fuel amount, and that is a float. So we're saying whatever number is passed to us in this, and again from the player controller we're calling update fuel meter with this number. We're sending the actual fuel amount that we have now, and then this is going to receive it and put it into a receive it as a float type value. So let's set up our brackets for this. And we want to do a couple things in this. We want to, of course, take that fuel meter and scale it down so it looks like it's getting smaller. And then we'll also do, just for fun, change the color from green all the way to red. So as their fuel goes down, it just has a little more obvious look to it. So again, we need to create some variables up top to start with. I will put mine right after the title texture. I think we need to make a connection to the fuel meter. So this fuel meter is a GUI texture, of course. And we'll also, we'll also need to get a the starting width. And in this case, just to explain this real quick, so if we have this, where'd my fuel meter go here? It's obviously very easy to apply a percentage to this if its width is already 100%, but a lot of the time you're probably going to have, like in our case, 80 pixel wide fuel meter, so we need to apply a 100% based on 80. So a little bit complicated, but it's going to make it work no matter what size your fuel meter here is. And we'll do that, number one, by getting the starting width. So I have a variable called fuel meter starting width, just to make it nice and obvious. And that'll be a float. And we need to add a function start so that on start we get that actual number. So here we'll say fuel meter starting width equals fuel meter dot pixel inset dot width. So what that'll do is right away grab this number here, the width for the fuel texture. So then we can apply, use that to apply 100% to 0% on it. So going back down to the fuel meter here. First thing we'll want to do is when we're updating this is change the width, of course, to scale it up and down. So we'll just say fuel meter dot pixel inset dot width equals, and then fuel meter starting width, and that'll be times the new fuel amount times 0.01. And the reason for the 0.01 is because, of course, we're actually getting the fuel amount as a 0 to 100 number, but what we want is a percentage, so essentially 0.0 to 1. So we just multiply this by 0.01 and it moves the decimal points and we have a percentage instantly. So that'll, no matter what the initial width of the fuel meter, it'll drop it down between its full and 0. And then second, we want to lerp the colors. So fuel meter dot color equals color dot lerp, and this is a special lerp made especially for changing colors from one to the other. And here again, making things a little bit complex, but not too bad. We're taking, usually a lerp goes from 0 to 1, but we're actually going from 1 to 0, a fuel amount of 1, essentially, down to a fuel amount of 0. So instead of saying the starting color to the ending color, we have to swap that around and go from the end color to the starting color. So we'll say color.red is where we want this to end up. and color.green is where it started. And then for the lerp amount, again the number from between 0 and 1 it has to be, is new fuel amount, once again, times 0.01. Still need to make that a percentage, basically, between 0 and 1. Okay, so we have that. Unless I'm forgetting something very obvious, I think that ought to work. Let's take a look. No errors yet. Oh, of course, in the GUI we need to make that connection between the fuel meter. Drop that on there. And now if we hit play, we'll see the fuel meter starting with has picked that up, and oops, it looks like we are instantly out of fuel. Let's take a look and see what's going on there. Simple fix. Our code is all good. Hooray! We just forgot the obvious. Fuel amount automatically defaults to 0. The same for fuel burn speed. So make sure your ship starts with some fuel. And this, of course, can be any number you like. 100 will make it work best with the script right now, so we'll keep it at that. And set your fuel burn speed. The higher number, the faster it'll burn away. So we set it at something like 20, and then hit play. Now we can see that burning away very quickly. And once it's gone, it is gone. Although we're still getting actual movement control, so let's go and make sure that is turned off in the script also. So here we see what you get for trying to rush these things. We have to, of course, set the have fuel to do something. So we're telling it it's false, but that's not actually doing anything at all at the moment. So the whole purpose to this is to disable any kind of control if we run out of fuel. So we'll simply go up to function update and make sure everything that is requiring fuel is checking for it. So I'm going to add a new if at the very top here. If have fuel, pretty simple. And then I'm going to grab everything that requires fuel, pretty much everything in function update actually. Yes it is. And drop in, oops, grabbed one extra thing, there we go. So just make sure those brackets line up. So that's everything within have fuel is everything that ought to be, and then outside is just, of course, the function update bracket. And now the only way any of this should happen is if we have fuel. Let's give this another try, fingers crossed. And we need to make sure have fuel is on when we start. Using up fuel. And sure enough, fuel is gone and we cannot move. Okay, so there we have it. A fuel meter for your game, and it's everything working properly. One thing you probably might want to add is if you have actual gravity. I guess in my scene here I don't have gravity, so I don't keep falling. But maybe say if the player has already moved off the edge of the map, sort of, so there's nothing to fall and crash on, you might need to add a sort of a kill zone underneath all this or something, so once they fall, they'll eventually die. Or you could just give them instant space madness, or create an entirely new lose scenario where simply, a new title screen pops up that says out of fuel. Something you can totally do based on any of the previous tutorials, so go ahead and give that a look. And next we have, let's see, we will do the music and data between levels, should be a good one. So let's start by creating the persistent game object first. So again, this is something that would just stay no matter whenever you load a level or whatnot. It's always going to stay there. It's always going to be the same object. It stays between levels, and it's obviously really useful for lots of things like again, saving player score, player mesh, etc. Good stuff like that. So we will let's see, first create just an empty game object, and I'm going to name it game info with an exclamation at the point at the front, just to make sure it stays up at the top there. And then create a script for this, and I'll call this surprise surprise game info, and drop that script right onto there. And then also, just the way the script is going to work is going to be checking tags. So I want to make sure that the game info object has the tag game info. I already have it here, but if you don't have it, just go ahead and add it to the tags. Make sure you don't add it to the layers by accident, but right there on the tags. So game info, add the game info tag, and then let's open up the script edit. So the first part of this is a very simple command for Unity. Simply don't destroy on load, and then we type the game object. In that case, it's just this object right here. So all that does is make sure that anytime we load a new level, this object simply does not get destroyed, even though normally it would. So that takes care of that part. Then you have the issue where if you have multiple levels and each of these levels has one of these objects in it, naturally you don't want to end up, or normally you wouldn't want to end up with multiple copies of this, especially if this is some sort of game info object. Or again, when we go on to the DJ, it'll be the same thing, or the the music object. So we have to make sure that only one of these is always around and it's always the right one. And the best way I've found to do that is to do a lifetime check. So basically, excuse me. Basically, when you start the game, whatever scene you're in, you'll generally want to keep that game info object and not any other. So we just keep updating its lifetime, and then every time we load a new scene, we check, and if there's any others there and they have a lower lifetime, those get destroyed, but we keep this one. So pretty straightforward, and it works just like this. We'll create a variable called myLifetime. Make it actually an integer is fine, and make sure equals 0 to start. And then I'm going to create a new function awake. And this, might have gone over this before, I think, but just to be sure, it's just something, a function that always happens right before start. So there's always function awake, then function start, then function update. So awake will always be first. And in here, we're going to check for all other game info objects, and then do some stuff to that. So create a variable called all_gi, and then we'll do gameObject. Find game objects with tag game info. And what that does there is real nicely just drops in every single object in the scene with a tag of game object into this array variable called all_gi. And then through that we can first check if all_gi.length is greater than 1. So we're checking if there's more than one game object. And if so, we need to do some extra work. So now we're going to look through each and every one of game objects and check which is the oldest one, basically, and that's the one we want to keep. Every other one we're going to destroy. So for the game object in all game objects, or game infos, sorry, we want to go through here and just see if its myLifetime variable is less than the one that we currently have. So we can just say if the game object, and we'll get the script component. And the myLifetime variable on that game object. So if that is greater than myLifetime, this current object here, then we want to destroy basically ourselves right here. Otherwise, or just normally, if this is still alive, we're going to add a lifetime counter. And even just to be safe, I'm going to put that in the function start here. Okay, so once again, what this is doing is, first of all, making sure this don't destroy and load, that we never destroy this object when we load a new scene. This variable here is keeping track of the number of times that this object has been initialized in a scene. And then we go through right away on awake and we check number one, are there any other game object or game info objects in this scene? If there aren't, of course we don't need to do anything, we'll just keep going, and of course add a new lifetime counter. This is, +1, starts at 0, now we're at 1. And that would be, if you load it from the main menu scene, that would happen right away and it gets a +1. Otherwise, say maybe we've loaded into our level. Now we're going to have two, probably one from the main menu where it started and one in this new level. So then we need to check through each of them, find the oldest one, keep it, and any of the youngers, we're going to destroy them. So those will be the ones that we don't actually want. So for the game info object in all game info objects, we just check. First of all, we grab the component of game info, which of course is the script that's on there, and then we check if the my lifetime variable within that is greater than mine right here locally, and if so, of course we destroy ourselves because this is a younger one. And that's it. That's just going to check and make sure that it stays alive when it should and doesn't when it shouldn't. And then of course you would add in all your other variables. Might it be like player score, maybe you'd have your player mesh, etc. All sorts of things. And then anytime you load a scene, it's going to stay there and you can keep pulling info from that. So really useful thing, and again, good question to ask, so glad we could go over it. And then let's just actually make sure this works here in the scene before we call it good for sure. Let's delete these since they're not really needed. So let's make sure no big glaring errors. Oops. Spelling is important. Destroy game object. Okay, so we have our game info in here with the script on it, and let's go ahead and add one also to the main menu. Make sure you save that. Oops, I already had one from some previous testing. Ignore that. Okay, so we're creating a new one here. Game info. Make sure it's tagged game info, of course, and drop that script on there. So if we hit play, the first thing that happens is the lifetime goes up 1. And now if we start a new game, sure enough, we only have this one with a lifetime of 1 still there. It's deleted the local copy that only had a lifetime of 0. So works good. Go ahead and use that for all sorts of things. Very, very useful. And let's take a look at getting the music to play continuously through your level. So back in the main menu, let's create a game object, just another empty one called !DJ, and a script for it. Again, just calling it DJ, and then attach that script to the object. So in this script, we can actually copy a bunch from the game info. Just like the game info, we don't want it to be destroyed whenever we load a scene. So I'm going to, I'll just take the whole thing and paste it. Oops. Control C, Control V. There we go. Okay, so now we're going to check. In this case, though, we'll be checking for any DJ objects. Not as big a problem in this case, except that obviously if you go back to the main menu, you don't want to double up and end up with two music players going on. So we'll just change a couple of variable names really here. So all DJs. We'll make sure we'll create a tag in a second or two. Dun, dun. So for the DJ and all DJs. Okay, that should do it. We just need to set up the tag DJ, and of course add it onto that. So add tag DJ, and then tag it as such. Okay. So that's set up, and then we want this script to actually do something. In this case, play some music. And more than that, anytime a music track finishes up, we want, of course, to move on to the next track, the next track, the next track. And if we get to the final, then jump back to the beginning. So right on function start, we want to start playing our audio. So we can just simply say audio.play. Of course, we need to add a audio component to this first. So with your DJ selected, component audio source. Make sure you turn off play on wake just in case, so we can initialize that through the script. Make sure loop is off and all that. And I think that's about all we need to set on there for now. Okay. Let's set the first track on it right away, actually. So we'll drop in. You'll notice we have these two new music tracks in here, DST Confuse and Green Sky. Go ahead and drop either one of those in there. And now in our variables, let's set up a array to hold all of the music tracks that you might have. So simply variable music tracks is going to be an array of type audio clip. Oops, there we go. And go ahead and drop each of the new audio tracks into there. And here I'm going to change what I said just a bit, as usual here, and just I'm going to assign the music track from within the script again, just so we don't have any problems. Something if you have the wrong one in the inspector or nothing. Either way, so audio dot clip equals audio dot lowercase clip equals music tracks 0. So the first music track, we're going to load it in right away at start and then tell it to play. So I'm going to make sure that's none to start with, just to see if this works. And if we hit play, okay, so it loaded it in, it's playing it, good stuff. Let's get back to the script here. Now just some simple things in the function update. We just want to check if this music ever stops, then we want to go on to the next one. So if not audio dot is playing, let me check if that is correct. Yep, so audio dot is playing. So if we're not playing anything, then what's happening, we've obviously finished the track and we need to move to the next one. So let's see, if current track equals music tracks dot length, then we want to go back to the start, otherwise we're going to go on to the next one. So not to get too ahead of myself here, basically we're going to check if the current track, which is another variable we'll need to create, we're going to check if we're already at the end of the playlist, and if so, go back to the start, otherwise we're going to just jump to the next track. So current track, and it is an int, and we just need to up that here, and then audio.clip equals music tracks current track. And again, if we're already at the end, then we need to just say audio.clip equals music tracks 0. Alright. We will also want to make sure this is length -1, since Unity uses in its arrays a 0 and up numbering system. So just as we're doing here, the first item in an array is 0, and just numbers up from there, versus starting at 1 and going up, unlike some other programs like Lua and such. So we have to make sure this is down 1 because music tracks.length is 2. However, the last track index is actually going to be 1 because it goes 0, 1, and 1 is the second, 0 is the first. Sometimes a little confusing to get used to. But anyway, we need to drop this down by 1 to make sure we're getting the proper track. So we set that. We also need to set the current track. Go 0 just to make sure we have that correct. And then of course just a audio.play and a audio.play here as well. Okay, so let's check this over. We're making sure it's not being deleted. On start, we're going to assign the very first music track and play it. And then during update, anytime the audio stops, if the current track is the final track, we're going to set the audio clip back to the very first one. We're going to make sure, of course, and reset the current track variable here back to 0 so we know where we are. And then set the audio to play, of course. Otherwise, if this is not the last track that just finished, we'll up the current track one and then play that next track, which we get from the number there, and play it. So that's it to play your music. Let's go ahead and test this in the editor, see if it works all right. So music starts up. Start a new game. It's still playing all right. I'm going to go ahead and pause the recording and make sure this continues on to the next one. And sure enough, there it goes. As soon as the music stops, in my case, I've noticed as soon as I click on the pause button on my record, Unity triggers it as a stop. But it works really easy. Didn't have to wait 5 minutes. That's very loud. So anyway, once the music stops, it goes ahead and moves on to the next track or jumps back to the first. So there you have it. What have we got so far? Fuel system setup, music and data transferring between levels, and now we just need to make the camera follow the player in a nice way. So let's move on to that one. Now, at this point in the tutorial, if you're looking at the time, you might be wondering how we're possibly going to finish without this getting ridiculously long. And I'll tell you how we are going to cheat. So open up your first level, or any level actually, doesn't really matter. And we're going to make that camera follow your player ship in a nice, smooth way. So go to Assets, and then Import Package, and choose the Scripts option. And we get this list of the scripts that we can import from Unity's own. And from here, let's just choose these, actually turn them all off by checking that top box there. And then we only need the smooth follow and smooth look at scripts. And click import. Go bring those in and compile them. This is one little thing, just always great to check through and see what Unity already has created for you. Usually a lot of really nice things. In this case, 2 perfect camera scripts that work just right to make the camera follow the player here. So once you have those imported, just go ahead and select the ship, and I'm gonna kind of hide as much as I can here so we have a little more room, and go ahead and just drag and drop on both of these. Smooth follow. Oh, I'm sorry, not onto the script, of course, or the ship, I mean onto the camera. So the camera, drop on the smooth follow and smooth look at, and then drop in the ship, of course, as the target. And you might want to set the distance to something around 20 and the height to be 0. And then these other 2 numbers we can always, tweak later. And if you hit play, camera jumps right in and follows it around. And if your particular player has a bit more speed than mine, you'll notice that it, oops, I ran out of fuel already. You'll notice that it will follow it around with a smooth motion. It's not just locked directly to it or anything like that. Let's see if I can test this a bit more. So that's pretty much it. Try messing around with these, make them different numbers. It's all gonna change exactly how it affects it just a bit more. See how it works for your particular game. As you can see there, now it's rocking around a bit more. Yeah, that's a simple way of doing that. If we were going to make an entirely new script to track the camera or track the player, that would possibly be an entirely separate tutorial we could go over perhaps. But since Unity has its own really just perfect scripts already set up, the smooth follow and smooth look at, it's probably best just to use those. And of course, you can always open them up, take a look and see exactly how they did it. It's very nicely commented and pretty short and simple. Nothing too complicated in either of those. So there we have it. Fuel system, music between levels, data between levels, keeping those consistent, and your camera following the ship around. So thanks for giving me some input on what you guys wanted to hear more for the tutorial, and see you guys in the next Unity Cookie tutorial. Thanks.